let's just see the next question. Question number 4 says that if Q 0, 1 is equidistant from the point P and R, then find the value of X and also find the distance QR and PR. So let's just first of all find the value of X. So as per the question, it is given to us that Q is actually equidistant. It is equidistant, means the distance of Q from P and the distance of Q from R is actually same. So let's just start the solution with this condition. That is, according to the question, it is given to us that the QP distance, or let us suppose if I am writing it as PQ distance, is equal to the RQ distance. It is mentioned to us in the question that the distance of these are actually is equal to each other. So let's just apply the distance formula over here. What is the distance formula? It is nothing but square root of x2 minus x1 whole square plus y2 minus y1 whole square. So I am taking the coordinates of Q as x2, y2 and the coordinates of P as x1, y1. So always remember, whenever I am writing PQ distance, so it means I am taking P as x1, y1, I am taking Q as x2, y2. So this Q is nothing but x2, y2. So this is x2, y2 and P is x1, y1. So the formula would be of the type 0 minus 5 whole square plus of 1 minus minus 3, 1 minus 3 whole square. Again, we are finding the distance RQ, means we are taking the Q as x2, y2 again and the coordinates of R as x1, y1. So this would be 0 minus x whole square plus 1 minus 6 whole square. So let's just sort it out. First of all, we have to take the square on both the sides, but before that, let's just solve it. So this would be nothing but of the form square root 25 plus of 1 minus, that is 1 plus 4, 1 plus 3, which is nothing but 4. So 4 whole square is nothing but 16, which is equal to square root of 0 minus x is minus x. So this is minus x whole square, means x square, plus of 1 minus x is minus 5 whole square is nothing but 25. So let's just take the square on both the sides. So if we'll take the square on both the sides, so taking square on both sides, if we'll take the square on both the sides, this would be of the form 25 plus 16 whole square, which is equal to square root of x square plus 25 whole square, and square root get cancelled with each other. At the end we are getting 25 plus of 16, which is equal to x square plus of 25. 25 get cancelled with each other, and at the end we are getting x square is equal to 16. If x square is equal to 16, it implies x is equal to plus minus root 16, and plus minus root 16 means the value of x is 4 and minus 4. The value of x is 4 and the value of x is nothing but minus of 4. So these are the values of the x, because in the first part we have to find out the value of x. So we are done with the value of x. So x is coming out to be 4 and minus 4. So this is our very first solution. Now let's just talk about, it says also find the distances QR and PR. So let's just find the coordinates of R first. So as R was of the type x, 6, so we have to generate two cases over here for the value of x as 4 and for the value of x as minus 4. So let us suppose if I am taking the case number 1 where I am taking x as nothing but 4. So if x is equal to 4, then R would be of the type 4, 6, then R would be of the type 4, 6, and we have to find QR and PR distance. So let's just find QR and PR. So let's just find QR and PR. Let's just take QR first. So let's just take QR first. So QR would be nothing but of the form R is definitely should be of the x2 y2 form, and this is x1 y1. So R is x2, means 4 minus of Q. Q is nothing but 0, 1 coordinate. So I am taking Q as x1 y1 and R as x2 y2. So this would be 4 minus 0 whole square plus 6 minus 1 whole square, which is equal to square root of 4 square is 16 plus 5 square is nothing but 25. So this is nothing but square root 41. And in the similar manner, we have to find the distance PR. So PR distance would be nothing but again of the form x2 minus x1 whole square. So this is 4 minus 5 whole square plus 6 minus 3 whole square. I am taking the coordinates of P as x1 y1 and Q as x2 y2. So this would be 4 minus 1 whole square is minus 1 whole square plus of 6 plus 3, that is 9. 9 whole square is 81. So this is nothing but 81. So at the end we are getting it as minus 1 whole square we have, and further we have the value as 81. So this is nothing but 81 plus 1, which is 82. Now let's just talk about the further distances, because this is nothing the case 1 in which we have find the value of QR distance and PR distance. Now let's just talk about the case number 2, when we have taken the value x as minus of 4. So if x is minus 4, then the coordinates of R would be minus 4, 6. It would be minus 4, 6. Now let's just again find out the value of QR and PR. So QR distance would be again of the form minus 4 minus 0 whole square plus 6 minus 1 whole square. Now I'm taking R as minus 4, 6, which is x2, y2, and again my Q coordinate as nothing but x1, y1. So x2 means minus 4 minus 0 whole square, 6 minus 1 whole square. So this is nothing but 16 plus of 25 again, which is nothing but root 41. Now let's just talk about the distance PR. So PR distance would be like square root of minus 4 minus 5 whole square plus of 6 minus of 3 whole square. So this is nothing but minus 9 whole square, which is 81 plus 81, which is nothing but 81 plus 81 is definitely nothing but 1. We have 1 and 1, which is 2, and 18 means 162. So this is nothing but the distance QR and PR in case of case number 2. So this is all about finding out the distance QR and PR for the two cases. Case 1 when we have taken x as 4, and the case 2 when we have taken x as nothing but minus 4. So this is nothing but the solution, that root 41, root 82, root 41 and root 162, they are nothing but the distances QR and PR for the two values of x.